Hi, I am Moulik.
And I'm Vardhan.
Have you ever thought about what would happen if you shot a rifle on the moon? But first, let's try to understand the science behind this.
The basic idea behind this is something called orbital velocity.
Now, suppose you shoot a bullet into space. Then its velocity can be broken down into two parts, up and forward. Now, according to Newton's second law, net force is equal to mass times acceleration. Also, acceleration itself can be broken down into the same two parts, up and forward. So, the rate of change of the up velocity is related to the up acceleration and forward velocity to the forward acceleration.
If we ignore the air drag, the forward velocity shall remain the same until it hits the ground. But along the up direction, there is a gravitational force which is trying to bring the bullet down. This means that the acceleration of the bullet along the up direction is negative g.
The gravitational acceleration experienced by a body, which in our case is the bullet, due to some other body, the moon in this case, comes out to be around gm upon r square. Now, if this bullet has to move in an orbit around the moon, this acceleration also needs to be equal to the centripetal acceleration of the bullet.
But what is centripetal acceleration, you ask? To understand that, you need to think about a different problem. Imagine an object steadily traversing a circle of radius r, centered at some point. If this object moves by an angular distance theta, then its velocity also changes its direction by the same amount, but its magnitude remains the same. Given this knowledge, we can think of velocity to be tracing another similar circle, but with its own magnitude as the radius, and the time taken to complete this circle is the same as the time our original object takes to complete a full circle. This means that its acceleration or the rate of change of velocity is v square by r.
Now, coming back to our original bullet trajectory problem, we can now say that our original acceleration is equal to the centripetal acceleration, and our velocity works out to be v is equals to under root of gm upon r. But what is so great about this result? Not much really on Earth, but on Moon, if you work out these values for the mass and radius of the Moon, you will see that it is ever so slightly smaller than the velocity of a bullet shot from a high power sniper rifle. So if you fire a bullet like that on the moon, there's a chance that after some time it will come back from behind and eventually hit you.